Welcome, welcome, welcome. So today we're going to go through the June 2013 AdMaths paper. Welcome, welcome, welcome. So today we're going to go through the June 2013 AdMaths paper. Easy, 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 soft. All right, let's look at this AdMaths paper. The list of formulas that you need. And so let's start. So the question starts by saying the expression x minus 2 is a factor of. So in order to find which one it is a factor of, what you need to do is plug in 2 in which of these equations and see which of them will give you 0. When you plug 2 in here, you're going to get 4 times 2 squared minus 2 times 2 squared minus 56. So I'm plugging in the 2's in the first one, and this one gives me 0. All right, so you substituted x as 2, and in the first one you get 0, and so A is the answer. If x minus 2 is a factor, then f of 2 equals 0. All right, that's it. Easy, soft, nice. Question 2, factorization. So what I want to do is, it have AB here, so, and I have an AC here, so I'm going to I like to group my AB and my AC together. So I have AB minus AC, and then I group my minus 3B and my plus 3C together. So from here I can factor out A, and I'm left with B minus C. And from here I can factor out minus 3, and I'm left back with B minus C. So what this works out to be is A minus B multiplied by B minus C. Now that option is A minus 3, actually, A minus 3, sorry. A minus 3 times B minus C. A minus 3 times B minus C is option C. Easy. Next question. It says, given that x plus 2 is a factor, then that means f of minus 2 is 0. If x plus 2 is a factor, then f of minus 2 is equal to 0. So we're going to plug in minus 2 in here. Minus 2 cubed is minus 8. Minus 8 times 2 is minus 16. Minus 2 squared is 4. 4 times 3 is minus 12. Minus 2 times minus 5 is positive 10. Plus p equals 0. So solving for p, we're going to get p is, bring over everything to the other side. 16 plus 12 minus 10 is 18. So p equal 18. Soft with a capital T. All right. Now the next question asks, which of these is this expression completely factorized? Now, in my estimation, the easiest way to do this is I'm going to look and determine a factor. What do I mean? So if x plus 2 is a factor, then f of 2 must be 0. So I'm going to check to see if x plus 2 is it. Is it x plus 2? Let me check. So I'm going to try x equal minus 2 because I really can't bother to factorize. Trying x as minus 2 in it, you're going to have 2 times minus 2 cubed plus minus 2 square minus 7 times minus 2 minus 6. Let's go again. 2 times minus 2 cube plus 2 times minus 2. 2 times minus 2 cube plus minus 2 square minus 7 times minus 2 minus 6. I get negative 4. So option A is out because this is not a factor. So option A out. So I'm doing it by elimination. For option B, if x plus 2 is not a factor, then that means that x minus 2 is good. So now for option B, I'm going to try x equal 1. I'm going to plug in x equal 1. All right. So option A is out. Since option A out, plug in x as 1. 2 times 1 cube plus 1 minus 7 times 1 minus 6. No, minus 1 don't work either. So option B out. So I'm going to try x as minus 1 as minus 1. So that means minus 1 have to work. All right. So that means it's between C and D. So what I'm going to do now is to determine which one of these it is, I'm going to try x equal 3 over 2. If I try x as 3 over 2, that would shoot option C. So 2 times 3 over 2 cube plus 3 over 2 square. 2 times 1.5 cube plus 1.5 square minus 7 times 1.5 minus 6. And so 1.5 don't work, and so it has to be option D. Option D. That's the answer. That's when you factorize it completely. And to check back your answer, you can multiply the product of these three roots. So 2 times minus 1 times minus 3, that should give you minus D over A. All right, so when you check it, 2 times minus 1 times minus 3 over 2, that's 3, and minus D over A is also 3. When you add these three roots, it should give you minus a half, and 2 plus minus 1 plus minus 3 over 2, that give me the minus half, so D is correct. Nice. Question 5. It says the roots of the equation are, to determine the nature of the root here, work out the discriminant, and the discriminant is b squared minus 4ac. So it's 6 squared times 4 times 5 times minus 2. That's minus 2? Yeah, minus 2. And so that works out to be 36 plus, that looks like 40. 36 plus 40 is 76. So if we get in 76, the roots are real and distinct. So the roots are real and distinct. Nice and easy, soft. All right, question 6. It says find the range of values of x for which this quadratic inequality is less than 0. So first thing you have to do is factorize this quadratic inequality. And you can factorize it to get x minus 2 times x minus 5 quite easily. That is less than 0. So if that is our solution region, then what you can do is sketch a graph to see what is happening. You have 2 and you have 5, and you want the part where x is less than, where y is less than 0. That's in here. In here is when x is between 2 and 5. That looks like option B. Soft. Question 7. Solve for the set of values of x for which 3x plus 2 is greater than x minus 2. Here now you can subtract x from both sides to have 3x minus x is greater than. You can subtract 2 now to get minus 2 minus 2. And so you get 2x is greater than minus 4. You divide through by 2 to get x is greater than negative 2. X is greater than negative 2, which is, that looks like option D. Nice. So now that we get x is greater than minus 2, question 8. F of x is 3x minus 4. If g of x is x, then g of x is, now if f g of x is equal to x, then what you need to know is, if f g of x is equal to x, then that means g of x is equal to f inverse of x. That is what this question is telling you. If f g of x is equal to x, then g of x is equal to f inverse of x. To find f inverse of x, what they tell us to do is call f of x y, and so y is equal to 3x minus 4. Then they tell us to interchange x and y to get x is now 3y minus 4. Then make back y the subject. To make y the subject, we add 4 to both sides, and after you add 4 to both sides, you're going to have to divide by 3. So x plus 4 divided by 3, that will give you y. So y is x plus 4 divided by 3, and this is therefore g of x. This is g of x, because g of x is f inverse. So that is g of x, x plus 4 over 3. Nice. Question 9. Which of the following is a function? To determine which is a function, you use a vertical line test. Where the vertical line detects more than 2 points, it's not a function. So this right here, this is a function. This is a function because the vertical line test only detects 1 point of intersection. So this is a function. So this one good. Let's check this one now. Vertical line test here detects 2 points of intersection. Here and here. So this is not a function. This is not a function. 2 points of intersection. So that means this girl right here, she's dating this guy from Y, and this guy from Y. And that is not right. We don't tolerate that. So this is not a function. We say this is not a function, all right? It's one to many, one X value to many Y values, one to many. Question 10, it gives us that h of x is 5x plus 2. And so it wants us to find out what is h of 2a plus 3. So h of 2a plus 3 is going to be equal to 5 times x is now 2a plus 3, and then we add 2 to it. And so when we do that, oh, by the way, this is h of 2a plus 3. So when we do that, what we're getting now is h of 2a plus 3 is equal to 5 times 2a is 10a plus 15 plus 2. And so h of 2a plus 3 is equal to 10a plus 17. All right, nice and easy, soft. That's 10a plus 17, which is option C. Nice. What to do next? It says a function is defined by f of x is 2 over x minus 3. Find f inverse of 1. So if you want to find f inverse of 1, you don't need to find the inverse function of this. F inverse of 1 just means you're solving f of x equal 1. That just means f of x is equal to 1. All right, so just set 2 over x minus 3 equal to 1. Set 2 over x minus 3 equal to 1. All right, and so you cross multiply, and so 2 is equal to x minus 3. And if 2 is equal to x minus 3, you add 3 to both sides, and so x equal 5. And so that means that f inverse of 1 is equal to 5. Nice and easy, soft. Here's another easy question. 2 to the minus half divided by 8 to the 1/3. 2 to the minus half, 2 to the minus 1 is a half, and then it is divided by 8 to the 1/3. 8 to the 1/3 is 2. So it's a half divided by 2, which is a quarter. Easy question, soft with a capital T. Question 13. Question 13 says 8 plus the square root of 5 times 2 minus the square root of 5 can be expressed as. Now 8 times 2, when you work that out, you get 8 times 2 is 16. Then 8 times minus root 5 is minus 8 root 5. Minus 8 root 5. And then 2 times root 5, that become plus 2 root 5. Nice and easy, plus 2 root 5. And then you have root 5 times minus root 5. That's just minus 5. But then 16 minus 5 is 11. And then minus 8 root 5 plus 2 root 5 is minus 6 root 5. And that takes care of that. 11 minus 6 root 5, solved. Question 18. Find the value of x. Oh, that's not 18, 14. Need to put on my glasses here. So find the value of x for which 4 to the x plus 1 is 2. If 4 to the x plus 1 is 2, then what we can do is rewrite this to base 2 and rewrite it as 2 to the 2 times x plus 1. And that is equal to, of course, 2 to the 1. This is equal to 2 to the 1. Nice. And so what we're actually getting right now is 2 times x plus 1. This is now 2 times x plus 1. That is equal to 1. And so what we're getting is 2x plus 2 is equal to 1. And so 2x is equal to 1 minus 2, which is negative 1. And so x is equal to negative 1/2. So that's what we're getting. The value of x is negative 1/2, which is option A. Nice and easy, solved. All right, question 15. Question 15 says, given that the log to base p of x is 6 and the log to base p of y is 4, find the value of the log to base p of x over y. Find the value. Now, there are many ways you could do it. Let's see. Well, by definition, if the log to base p of x is 6, then it is fair to say that x is equal to 6 to the p. And then it is also fair to say that y is equal to, oh, my apologies. X is equal to the base. The base is p. So x is equal to p rather to the power of 6. And y is equal to p to the power of 4. And so that means that x divided by y would be equal to p to the 6 over p to the 4 is p squared. And so therefore now the log to base p of x over y is log of p squared. And the log of p squared is 2. How do I know that? By rules of logarithm, we can bring down the 2 and you get 2 times log to base p of p. And that is 1. So this works out to be 2. All right, question 16. Given that a and b are the roots of the equation x squared plus 3x plus 4 equals 0, what is the value of a plus b all squared? Now to work this out now, right, first thing you have to write down is the fact that a plus b all squared, a plus b all squared is, you need to write down what is a plus b. A plus b is the sum of the roots. A plus b, the sum of the roots is negative 3. So that works out to be negative 3. That's a plus b. Negative 3 squared. And negative 3 squared is 9. So that's a plus b all squared. Easy. Solved. Next question. Find the common ratio of this sequence. The common ratio R is T2 divided by T1. So it's 12 divided by 8. 12 divided by 8. Well, 4 into 12 or 3 into 12. Wait, 4 into 12 3 times. 4 into 8, 2 times. That's 3 over 2. 3 over 2. Soft with a capital T. Next question. Find the sum of the odd integers between 10 and 50. Odd integers between 10 and 50 is 11 plus 13 plus 15 plus 17 plus all the odd integers all the way up to 49. That's what we're adding. That is what we're adding. If this is what we're adding, all right, the sum of all the odd integers from 11 up to 49, then this is an arithmetic progression with the first term 11 and the last term 49. Now, if the last term is 49, we need to find out how many terms this is. To find out how many terms it is, we set 49 equal to A, which is 11, plus n minus 1, n minus 1 times D, but the common difference is 2. So it's 11 plus 2 times n minus 1. Nice. So subtracting 11 from both sides, we're getting 38. And so we get 38 is equal to 2 times n minus 1. And so looking at this, it looks obvious to me that n equal 20. N has to be 20. N equal 20. Since n is equal to 20, then what we're finding is S20, and S20 is equal to n over 2, which is 20 over 2 into A plus L, where the first term A is 11 plus the last term of 49. And that's what we do. 11 plus 49 is 60. 60 times 10 is 600. And so this works out to be 600. Easy question. Soft. Next question. For the arithmetic progression, what is the nth term? So first thing we notice is that the common difference D is -7 minus -12. -7 minus -12, that look like +5. Since the common difference is +5, then the nth term is equal to the first term -12 plus n minus 1 times D. N minus 1 times 5. And so that works out to be -12 plus 5n minus 5, which works out to be equal to, that looks like 5n minus 17. Nice. So if you put n as 1, you get -12, n as 2, you get -7, n as 3, -2, n as 4, 3, and so forth. So that is 5n minus 17, soft. Question 20. Question 20 says, a long distance runner runs the first kilometer of a race in 3 minutes and 45 seconds, but finds that his speeds drop steadily so that each kilometer he takes 12 seconds more to complete the preceding. The time taken to cover the first 12 kilometer is, so first thing we notice is that this is an AP. The first kilometer he takes 3 minutes and 45 seconds, which is 225 in seconds. Then he takes 237. Then he takes 249. Then he takes, and so forth, right? So this would be the time for the first kilometer, second, third, up to the 12th kilometer. So what we need to do is find the time taken for the 12th kilometer. For the 12th kilometer, n equal 12, we know that the arithmetic progression is A, 225, plus n minus 1, which is 11, because it's 12 minus 1 times the common difference of D, which is 12. That gives us 225 plus 11 times 12, that is 357. So that's the time taken to cover the 12th kilometer. This is the time for the 12th kilometer. This is the last one. This is the 12th kilometer. So what does that help us with? It helps us because we know this. We know that now the sum is equal to n over 2, which is 12 over 2, 12 over 2 times a plus L, where a is the first term of 225 plus the last term of 357. Nice and easy, soft. So you put all of this in the calculator and that will give you the time in seconds. 225 plus 357 multiplied by 6 is 3,492. But that is 3,492 seconds. And so you have to divide it by 60 to get it in minutes. Divide it by 60, you get 58 minutes and 12 seconds. Easy, soft. Now it says that the lines 7x minus 4y plus 25 equals 0 and 3x minus y minus 5 equals 0. From the second equation, I'm going to multiply it by 4 to get 12x minus 4y minus 20 equals 0. Then I'm going to add the two equations because I have a 7x minus a 4y plus a 25 equals 0. Then what can I do? What I can do then right here now is I can go ahead and proceed to add these two equations. Well, not add them, let's subtract them. I can subtract them, and after I proceed to subtract them, 12x minus 7x is 5x, and then minus 20 minus 25 is minus 45, so I get 5x minus 45 is 0, and so what I get is x equal 9. If x is equal to 9, there's only one answer with x being 9, which is option D. Easy, soft. Question 22. It says the line through the points P, K2, and Q is parallel to the line 3x plus y equal 3x plus y minus 21 equals 0. Find the value of K. Now this line is parallel to the line PQ, parallel lines of same gradient. And so rewriting this line, making y the subject, y is negative 3x plus 21. Since y is negative 3x plus 21, then what we know is the gradient is negative 3. Since the gradient is negative 3, what else do we know? We know that negative 3 is equal to the gradient of PQ. So y2 of 8 minus, so 8 minus 2 over k minus 8 minus 2 over 6 minus k is negative 3. All we have to do now is solve for k. So 8 minus 2 is 6. So what we get is negative 3 is equal to 6 over 6 minus k. Negative 3 is equal to 6 over 6 minus k. And we know that 6 over minus 2 is 0. We know that 6 over minus 2 is minus 3. So that means that 6 minus k equal negative 2. And since 6 minus k is negative 2, bring minus 6 over here. That's minus 8, so k must be 8. 6 minus 8 is negative 2, so k is 8. Easy question, soft. Question 23. It says the point of intersection of the line with equation x plus y equals 7 and x squared plus y squared is 25 are. We need to solve them simultaneously. You don't even need to do it. 3 plus 4 is 7 and 3 squared plus 4 squared is 25. So no, 3, 4 is the answer already. See it here? D. We don't even need to work it out. 3 plus 4 is 7. 4 plus 3 is 7. Come on, man, we're done. Nice, no working out there, so. All right, it says the vector A is given by 5i plus 12j. A unit vector parallel to A is? A unit vector parallel to A, well, unit vector that is parallel to A, we need to find a unit vector of A. A unit vector of A would be 1 over the modulus of vector A, which is 1 over the square root of 5 square plus 12 square, and that is multiplied by vector A itself, and vector A is 5, 12. I'll put it in vector form. 1 over the square root of 5 square plus 12 square is 13. So what we're getting is 1 over 13. This is giving us 1 over 13 times 5, 12. Nice. So which one of 1 over 13? See it here? Easy question. Solved. All right. Now it says if theta is between pi and 2 pi, what is 2 cos root 3? Now, first thing you have to do is divide both sides by 2. Dividing both sides by 2 will give you the cos of theta is equal to root 3 over 2. If the cos of theta is equal to root 3 over 2, we have to remember that cos is positive in 2 quadrants. Cos is positive here and here. But they don't want the angle in the first quadrant, they want the angle in the second quadrant. We know that the cos of 30, we know the cos of 30, right? We know that the cos of 30 gives us this answer. So the angle in the first quadrant would be pi by 6, but pi by 6 is not the answer that they want. They want the angle in the fourth quadrant, which is 2 pi minus pi by 6. 2 pi minus pi by 6. 2 pi minus pi by 6 is equal to 11 pi by 6. 11 pi by 6, which is option A. Nice and easy, soft. Now question 26. Question 26 says the position vectors of A and B relative to an origin 2, 5, and 3, minus 1 respectively. All right, the position vectors of A and B relative to the origin O, and they want the acute angle AOB. What I like to do is picture what is going on. I like to do like a rough sketch. Vector A, let's say A is 2, 5, 2, 5. If you have 2 right here and 5 right here, this would be A. And you have vector B is 3 minus 1. Let's put 3 right here and minus 1 here. So this is vector B. This is vector A. And what they want us to find is AOB. AOB. So they want us to find this angle in here. To find that angle in here, you need vector OA and vector OB, which we already have. And so first thing we need to find is the modulus of vector OA. The modulus of vector OA is equal to the square root of 2 square plus 5 square, which is the square root of 2 square plus 5 square, square root of 2 square plus 5 square, and the square root of 2 square plus 5 square is, that's 2, 4, 25, that's the square root of 29. So that's the modulus of OA, the square root of 29. And then now we need the modulus of OB. The modulus of OB is going to be equal to 3 square plus 1 square. So it's the square root of 10. All right, nice. And next thing we need is a dot product. We need a dot product of 2, 5 times the dot product with 3 minus 1. This dot product will work out to be 6 minus 5, which is equal to 1. And so the cosine of the angle is equal to, so the angle theta is equal to cos inverse of 1 divided by the square root of 29 times the square root of 10, which is the square root of 290. Nice and easy, soft, capital T. Option A, too easy man, soft. Question 27. Given that the cos of x is 3 over 5, what's the sine of 2x? So always draw your triangle as soon as you get these questions. Boom. So this is angle x. All right. And they say the cos of x is 3 over 5. That means that the opposite is 3 The hypotenuse is 5. Cos, my apologies. The adjacent is 3. The adjacent is 3 and the hypotenuse is 5. So the opposite has to be 4, because 4 squared plus 3 squared is 5 squared. So then what is sine 2x? So the sine of 2x, as we know it, the sine of 2x is given by the formula 2 sine x cos x, 2 sine x times the cos of x. Oh, good now, because guess what? We know what is sine x now, so it's going to be 2 times sine x. Sine x is 4 over 5. And then what is cos x? Cos x is 3 over 5. Cos x is 3 over 5, so good now. So 2 times 4 times 3 is, that's 12, times 2 is 24, so this is 24 over 25. Nice and easy, soft. 24 over 25. Lovely. Question 28. Question 28 says, what is the arc length in meters of the outer edge of the protractor marked? What is the arc length x in meters along the outside edge of the protractor in the region of the angle AOB? So what is this angle x? What is this length x? The length of x is equal to r times theta. And let's look at theta. Theta is q. Now notice that the angle right here is 45. 45 is actually pi by 4. And so that means that x is equal to r, the radius of 1.5. 1.5 can be written as 3 over 2. So it's 3 over 2 multiplied by theta, and theta is pi by 4. And so x work out to be equal to 3 pi by 8. Easy question, soft. Question 29, sketch the sine graph. Now, one thing we know is that you can try values to see which one works. When you put the sine of 0 is equal to 0. So look at this. When x is 0, y is supposed to be 0. So option A out and option B out. Now this one gives us 0. But now what's the next thing we need to do? Try x as pi by 2. We know that the sine of pi by 2 is equal to 1. So look which one of the graph then give us sine pi by 2 is 1. This is pi right here. And so this is not giving us that. Pi by 2 is right here. So this one of pi by 2, which is in between 0 and pi, and that's giving us 1. So the only option is option D. It can't be C because this is pi, but the sine of pi is 0. So it's D, soft, capital T. Question 30. It says if the sine of x plus 20 is cos x, then the value of x is, now what is the value of x such that the sine of x is equal to this? Now there's a formula that relates cos and sine. It tells us that the sine of x minus a is equal to the cos of a. So there's a formula known as the sine of x minus a. So it would be x minus minus 20. And that's equal to the cos of a. This is the formula actually. The sine of, it's really pi by 2. All right, let's not use that. That's more for pure math. So let's just stick to odd math. Don't want to be going into too much identities. So if you were to expand this out, it would be sine x cos 20 plus cos 20. Sine x plus cos 20 plus sine 20 cos x, and that's equal to the cos of x. Then what would you do is you want to make cos x the subject. So you bring over the other one over there, and you'd left back with We're solving for sine, we're solving for this. So this cos 20 is the cos of 20. The cos of 20 is 0.41. So you get 0.41 sine x plus, now this right here, the sine of 20 is, wait, cos of 20 is not 0.41. My calculator is not in the best of mood. The cos of 20 is 0.93. So 0.93 sine x plus the sine of 20 is 0.34 times the cos of x. That's equal to the cos of x. Then what we can do is divide both sides by the cos of x. You can divide this entire thing by cos x. Go ahead and do it. Do it. Do it. Divide by the cos of x. Dividing both sides by the cos of x, what you're going to get is 0.93 sine x over cos x give us 0.93 tan x, and then you get plus 0.34 cos x. Cos x over cos x is 1, so you get 0.34 equal cos x over cos x is 1. So now you get 0.93 tan x is equal to 1 minus 0.34 is 0.66. And then you divide both sides by 0.93 to get tan x is equal to 0.66 divided by 0.93, which is 0.71. And then you take the tan inverse to get what is x. And so x equal tan inverse of 0.71. You get 35 degrees. 35. X equal 35, roughly. X is 35. Easy question, solve. Now, what is the sign of alpha plus 45? Now, when you expand, look at this. These three have minus in it. When you expand the double angle of sine, it only come out with a plus. So clearly these three out of the equation, so it's only option A, soft. What is 4 pi over 5 in degrees? So remember, pi is 180, so it's 4 times 180, and then you divide that by 5, which is 144, because that is just easy maths. Easy question. If the sine of theta is 5 over 13 and theta is obtuse, what is tan theta? So if you draw your quadrants, then your angle is in the second quadrant, or your triangle is in the second quadrant. So let's picture the triangle in the second quadrant. Let's say this is your angle, theta, all right? So the opposite is 5. Opposite is 5. The hypotenuse is 13. Then the tan of theta, then this side down here, so must be negative 12. And so that means that the tan of theta is opposite. So the tan of theta is opposite of 5 over negative 12. Because we're in the second quadrant. 5 over negative 12, option B, soft. Question 34. Question 34 says, the trigonometrical expression sin x over 1 minus cos x plus sin x over 1 plus cos x is, first thing is you have to find the LCM. The LCM of these two is just going to be 1 minus cos x times 1 plus cos x. So we just multiply them across, 1 minus cos x times 1 plus cos x. Nice and easy. Now 1 minus cos x into this leaves 1 plus cos x, 1 minus cos x into 1 minus cos x times 1 plus cos x leave 1 plus cos x. So what we get is 1 plus cos x, and we have 1 plus cos x is being multiplied by sin x, and then we have plus 1 plus cos x into this leaves sin x times 1 minus cos x, and we're good. And then now, what you can do is you can realize that you can factor out sin x in the numerator. So in the numerator, you factor out sin x, then you're left back with 1 plus cos x plus 1 minus cos x, and 1 plus cos x plus 1 minus cos x just leaves 1 plus 1, because the plus cos x and the minus cos x cancel each other. And then you're dividing it by 1 minus cos x times 1 plus cos x is 1 minus cos square, and 1 minus cos square is sin square x. So this cos x cancels this minus cos x, and so you have 2 sin x over sin square. A sine cancels the square right here, so it works out to be 2 over sin x. That's your answer, 2 over sin x. Easy, straightforward, soft. 2 over sin x. Nice. Moving right along. Differentiation time. Y equal 1 plus x cubed square rooted. What's dy dx? So first thing you have to rewrite it. Dy by dx is y prime. You have to rewrite this as 1 plus x cubed. You have to rewrite it as 1 plus x cubed to the half power. Write it as to the half power. So dy by dx is carried on the power a half. Then you subtract 1 from the power to get 1 plus x cubed. And then when you subtract 1 from the power, you're going to get minus a half. And then you multiply it by the derivative inside the bracket. So you multiply it by 3x squared. Nice. When you multiply it by 3x squared, you're getting, putting it back together now, you're going to get 3x squared divided by 2 times the square root of 1 plus x cubed. Nice and easy, soft. 2 times the square root of 1 plus x cubed. That's option B, soft. All right. It says the gradient at x equal pi by 6 for sine x is, first thing we have to differentiate y to get dy by dx. And when you differentiate sine, you're going to get cos. So dy by dx is cos x. Now, when you differentiate sine, you get cos. Now you need to plug in x as pi by 6. Plugging in x as pi by 6, you get the cos of pi by 6 or the cos of 30. The cos of 30 is root 3 over 2. As we plug x as pi by 6 right here. Root 3 over 2. Nice. Question 37. It gives us an equation and we need to differentiate it and find dy by dx. So to find dy by dx, we know that this is like a v and a u. It's v du plus u dv. So dy by dx, that's just going to be equal to v du plus u dv. So it's equal to v, which is x squared, plus 2 v times du. Du works out to be, du gonna work out to be carried on the power of 3, subtract 1 from the power of x minus 1, all square, plus u dv. So write down our x minus 1, all square, and then this is multiplied by 2x. Now I noticed that both of them have x minus 1 all square in common. So I'm going to factor out x minus 1 all square. Factoring out x minus 1 all square, what I am left back with in this bracket is, this look like factoring out x minus 1 all square. I'm left back with 3x squared plus, that's 3x squared plus 3 times 2 is 6. Then I factor out all right. This should be x cubed, by the way. Then I factor out x minus 1 right here. This one right here should be x minus 1. Let me try and pretty it up. It should be cube. Factor out x minus 1 right here, get back plus. Let me see. X minus 1 times 2x. X times 2x is 2x squared. So I get 2x squared right there. And then I have minus 1 times 2x is minus 2x. Nice. So that's what I get. Simplifying this together, it's clear that 3x squared and 2x squared is 5x squared. So I'm going to get 5x squared minus 2x plus 6. That is option C. Easy. So, moving right along. It says if y is equal to x squared over x plus 3, find dy by dx. So to find dy by dx, or y prime is equal to, you start with the bottom of x plus 3 times the derivative of the top. Start with the bottom times the derivative of the top, which is 2x minus the top of x squared times the derivative of the bottom. The derivative of the bottom is 1 all over the bottom square, all over x plus 3 squared. That's using quotient rule. It's u dv minus v du over v squared. That's what I did. So y prime is equal to, now 2x squared minus x squared just leaves. So this is 2x squared minus x squared. That's just x squared. And then I have 3 plus 2x is 6x. So I have x squared plus 6x in the numerator. X squared plus 6x over x plus 3 all squared. And so what you can do is factor out x from the numerator. Factoring out x from the numerator, you get x times x plus 6. Easy, soft. Question 39, it says y is equal to x squared plus 16 over x. And so if y is equal to x squared plus 16 over x, then I can rewrite y as x squared plus 16x to the minus 1. And if this is y, then what can I do? Well, I can differentiate it first to get y prime is 2x minus 16x to the minus 2. After I do that, what do I do next? What I do next is I can go ahead and differentiate it again to get y double prime is equal to, differentiating 2x, I get 2. And I carry down this, carry down the power to get plus 32 times x to the negative 3. But x to the negative 3 is 32 over x cubed. That's option B. Nice and easy, soft. All right, question 40.